Welcome to Math with John. This video will cover mostly the arithmetic of negative numbers with an introductory section covering some of the types of numbers that there are. Types of numbers. Mathematicians have defined many different number systems over the centuries. Some of them are listed here. The set of natural numbers, or counting numbers, consist of the numbers 1, 2, 3, so on and so forth, forever. The set of whole numbers consists of the numbers 0, 1, 2, 3, so on and so forth, and is just the set of counting numbers plus the number 0. The set of integers consists of the whole numbers plus the negatives of the natural numbers. So this set consists of, well, ... minus 3, minus 2, minus 1, 0, 1, 2, 3, ... forever and ever in both directions. There are also two other names used for two of these sets. Non-negative integers is another standard name for whole numbers. Positive integers is another standard name for natural numbers. The set of rational numbers consists of all the fractions, with the numerator being any integer and the denominator being any positive integer. This includes all of the integers, includes 0, and includes the negative fractions. The set of irrational numbers consists of all the rest of the numbers, such as root 2 and minus root 2. There are infinitely more irrational numbers than rational numbers. The numbers that we mostly study, integers and rational numbers, are just the few that are easiest to understand. Absolute values. The absolute value of a number is defined in the following way. If a number is 0 or positive, then the absolute value is itself. If a number is negative, then the absolute value is the minus of itself. The absolute value of all numbers is greater than or equal to 0. Since minus 1 times minus 1 is equal to plus 1, we get that the minus of minus x equals to x. This leads to equations such as the absolute value of minus 10 is equal to 10. Other examples. The absolute value of 5 equals the absolute value of minus 5, both of which are equal to 5. The absolute value of 0 is 0. And the negative absolute value of a non-zero number is less than 0, regardless of whether the number is positive or negative. So the negative of the absolute value of minus 5 equals to the negative of the absolute value of 5, and that equals to minus 5. The arithmetic of negative numbers. The positive numbers are numbers that are greater than 0. The negative integers are their mirror images, but less than 0. These are the arithmetic rules for dealing with negative numbers. Addition. For the rest of this video, x and y will be variables that are greater than 0. The point of this restriction is to reduce the issue of solving arithmetic problems, including negative numbers, to the simpler issue of solving problems with positive numbers only. So adding two positive numbers is the issue we know how to deal with. 6 plus 8 is equal to 14, and 9 plus 7 is equal to 16. Nothing new here. The next problem adds something new. If you are adding up minus 8 and minus 6, then the first step is to factor out the minus sign from the expression, simplifying this to minus 8 plus 6. Then the problem of what is minus 8 plus minus 6, it becomes the minus of 8 plus 6, and that is minus 14. So minus 8 plus minus 6 is equal to minus 14, and minus 7 plus minus 9 is equal to minus 16. If one number is negative and the other is positive, then this becomes a subtraction problem. The simpler form of subtracting is a bigger positive number minus a smaller positive number. If you have x plus minus y or minus x plus y, then the problem can be converted to a subtraction of positive numbers. A possible additional step is to use equation B to ensure that the smaller number is being subtracted from the larger number. Be very careful of minus signs. In equation 1, 9 plus minus 4 is the same as 9 minus 4, and that is 5. Equations 2 and 5 are the shortcut and long versions of 5 plus minus 8. In equation 5, the 5 minus 8 expression has the bigger number 8 being subtracted from the smaller number 5. So equation B is used to reverse this with an additional minus sign showing up to make the equations accurate. Equations 3 and 4 are variations of the first two equations, but they look a little bit different since the negative numbers are listed first. This can make it look confusing. Practice a few of these on your own and figure out which method is easiest for you to understand and use. Subtraction. Subtraction is just the reverse of addition, and in many cases, subtraction is reduced to a variation of adding numbers where one or both are negative. X minus y is equal to x plus minus y is a reverse of what we had with the addition rules. The subtraction problem can thus become an addition problem, possibly with complicated minus sign issues. X minus minus y being equal to x plus y is a result of minus 1 times minus 1 being equal to plus 1, as discussed previously. Equation 7 is a standard subtraction problem. Equation 8 is the same as the last steps of what was covered in how to add negative numbers to positive ones. Equation 9 is an example of the fact that subtracting the negative of a number is the same as adding that number. Equations 10 and 11 have the complexity of equation 9, with the second step consisting of adding a negative number to a positive number with the negative number written first. Multiplication and division with negative numbers only differ in that you have to keep track of the number of minus signs. If there is an even number of minus signs, 0 or 2, then the answer is positive, and if there is an odd number of minus signs, like 1, then the answer is negative. The x and y equations show the general formulas for solving these kinds of problems. The 7 times 8 equations show specific examples of each general formula. Thank you for watching this video. Please like and subscribe.